Wow! Wow. That was fast. Such enthusiasm for math class. I mean, amazing. Such enthusiastic. Can't wait to learn, you know? Like, eager to flex their brains. Exercise the third eyes. Wait, what? That's not. I'm not teaching XYZ axis. Wait, is that what it says? Oh, no, I don't think I'm teaching Calc 3 anytime soon. Oh, Battling Storm. Wow. Insane. No, multivariable is Calc 3. That's right, Crow. Okay. Get all our stuff going here. All right. I have my background all safe and secure. Right there. I'm gonna put a pen here so like I'm professional. Now, you memorized your way out of multivariable. Should have been here in the summer when I taught it. All right? Okay. Welcome back, class. Hope you had a great quarantined Halloween. Safe. Now Halloween's over, so no more pumpkins. I need to teach you one more thing about alternating series, and then I just wrote then. Then move on. All right. So the first thing I'm going to teach you is called this. First thing I'm going to teach you. It's an awesome thing. And then I'll show you an example of that, how to use that. And then maybe a story. Do y'all want a story before we move on to the next thing or not? Let me poll. Let me ask the audience. You want a story? Yes. Wait, let's make it official, folks. Let me ask everyone. 2-minute poll. The story will be very embarrassing for me. It'll just ruin my reputation. We'll do. If you want the story, I'll show you a story, and then we'll move to the next topic. Hopefully, we can reach there. Okay? That's the plan. Okay. First things first. There's a poll going, so go ahead and participate. Participate in our own little democracy here. Participate. Okay. What the heck is this stuff? I'm going to teach you this thing, the green box, real fast. Okay, what's this all about? Here's the situation. Okay. Situation is like this. Imagine you have an alternating series. A real good one. Oops. Oopsies. Well, you know, I'm writing it so that A1 is a positive number, A2 is also positive, but I made it negative by putting a minus sign. I'm just writing the pluses and minuses in so that you see it's alternating, okay? All the AIs are positive numbers, say. You have a real good one, meaning it obeys the two conditions of the alternating series test. Decreasing hop sizes. The yellow frog's hops are decreasing. They're not increasing. And they eventually become 0. Wow, look at this result. 100% say they want to hear a story. Okay, I'll give you the story after I teach you this stuff. Learning first, then story. Okay, all the hop sizes are going down, and they're going down towards 0. Okay, these are the two little pieces you need to verify if you want to execute the alternating series test, right? Let's call those real good. Okay, you got a real good alternating series. Then the good news, only in this setting do we have such a powerful result. The great news, it's possible to get some kind of handle on the error between a partial sum and the true number. It's possible. And that's what we're going to learn. This is great news. You can get some great info about how wrong a partial sum is compared to the true sum. Which I'll call S. All right? Why do we know that the true sum exists? Because we're in the alternating series test hypothesis. That's what I mean. Alternating series test will say then, for these kinds, you have an actual number, S, that you're staring at. The series adds up to a finite number. But whenever you take a partial sum, it's always an approximation of the true number. So the question becomes, how good of an approximation is a given partial sum? I'm now going to show you an awesome formula. It says, if you have that good kind of alternating series, let's call them real good. Real good like. The real good like. I want to speak in the local language. If you got a real good like alternating series, which I showed you what that meant, those two things, then this distance, this error, is at most the size of the next term. Okay, so let me read that. Let me read that in words. Let me read that. Let me read that in words. Quote that. Let me read that in words. Okay, so this, the crappy partial sum. You went up until capital N and you got tired and you stopped. I can't add infinitely many numbers. I'm just gonna stop. I'm gonna collect what I got. This true number. Who knows what it is? I don't know what it is. But look at what this is saying. This is saying with 100% confidence, the crappy partial sum, its distance to the true number, that's what absolute value of subtraction means, its distance to the true mysterious number is at most. Just read that next term. Next hop size. This is actually quite powerful because this tells you, this gives you some confidence in how close you are to the true mysterious final sum of this real good like alternating series. Okay? Okay. So I'm going to tell you why this is true. Why? This is the error bounding magical formula. Why is it true? It's actually obvious. This thing is obviously true. We just have to draw the hopping frog. Okay, let's go get that frog. Where is it? Right here. Conveniently, I have drawn it ahead of time because I prepare my lectures well in advance. All right, so here's our situation. A1 minus A2 plus A3 minus A4. Why am I doing this with my hands when I can just do it with a frog? A1 minus A2 plus A3 minus A4 plus A5 minus A6. Hop size is going to 0. Frog has to stabilize. Frog is trapped. What's the eventual location of the frog? It's the quantity called S, because that is literally the summation. A1 minus A2 plus A3 minus A2. So S is over there. But hey, where is S4? Where is the fourth place that the frog visits? Well, let's look at it. It's right here. Look. S4 is right here. This spot on the number line. And just, this is hard to believe, but all that the error bound is pointing out is that the distance between S4 and S, this distance, is less than or equal to the fifth hop size. This is obvious, because where the heck is the fifth hop size gonna go? It will, of course, overshoot the eventual place where the frog stabilizes. Here, this is the fifth one has to be like this. It can't be before S, because then the frog would have to get trapped into that little parabola somewhere. So the fifth hop size, of course, overshoots the distance from S4 to the true eventual position. It's just obvious in the picture. The fifth hop size, which is the width of that hop, has to be bigger or equal to S4 to S, the distance from S4 to S. And then just, this is true for, there's nothing special about 4. It's true for any partial sum. At any stage, the next hop will overshoot, either forward or backwards, your current location to S. It's just a simple observation about this movie. And so that's why the error bound formula is true. Okay, fantastic. Oh, will it ever reach S? At any finite moment? Maybe not. But is there one particular value which it keeps getting closer and closer to eventually? Yes, the limit exists. The limit of the partial sums exists. The series converges. This is one of the puzzles of infinity. Okay, this is part of becoming comfortable with infinite processes and thinking about the end result of an infinite process. It takes maturity. We're building it as we go. Okay,
Wow.
The primordial frog doesn't get to 2 at any finite stage. But 2 is the definitive spot which it gets closer and closer to.
Wow.
Not 2.1, not 1.9, it's 2 that it gets closer and closer to.
Wow.
Okay. Awesome. Now you want to see this in action? Let's see this in action, folks. Let's see this in action. Let's put up a series up. Let's put up a series up. And this is a alternating series, and it's the real good like ones. It goes like this. Look at that, it's alternating. Let me write it out fancy for you. Alright, that's fancy, elite. That's how you write it, okay? Alright. Does it obey the two properties of a real good like alternating series? Is it real good like? Yes and yes. I leave it to you to check that. Okay? Good. So this series converges by alternating series test. This is a number. Actual number. What the hell is that number? I don't know, okay? I don't know what that number is. I do. I know it because I've taken many more math classes than you, but I'll reveal it at the end, okay? But I don't know it. I don't know it. Okay? But look, check out what this error-bound formula tells me. Look at the amount of information I can get. I don't know S. But if I go up to the 9th partial sum, wait, let's I went 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, this is S sub 9. If I do this finite math problem, which you learned how to do in 3rd grade, no calculus, a real math problem, not fake news. You do that problem, okay? Since I know the error-bound formula, I know the following. I guarantee you that the distance from the true mystery number to this number, I guarantee you that this distance is less than or equal to the 10th hop size. The next term here, let's see what it is. It's 1 over 10 squared. Which is another name for 1 divided by 100. Imagine this. You don't know what S is, but you can guarantee that S sub 9 is at most 0.01 away from the true value. You don't know the true value, but you can guarantee an amount of closeness. It's an awesome thing, the error-bound stuff. Even back in Taylor polynomial chapter, it was an awesome thing. You could guarantee a closeness. You can't figure out S necessarily, but you can guarantee a closeness. That's the utility of this error bound. It is actually useful. Let me say it another way. Let's do it another way. I can go and calculate S sub 9. If I calculate S sub 9, which I can do because it's a finite frickin' sum. If I calculate S sub 9, then the answer, the true answer, will agree with S sub 9 up to the 2nd decimal. What does that mean? How do you say it? I haven't been to school in a long time. 2nd decimal, like 1 point. Like these digits. It'll be that close. You'll be that close that you'll agree up until that many digits. Hundredths, 2nd decimal, point 2nd decimal. It's all abstract, so I'm gonna do it live. I'm gonna do it live. All right, it's very abstract. Check out this calculator. What? Why are there ads in my calculator? Okay, don't pay attention to that. Don't do what they're telling you to do down there. Don't look at that. Okay, let's do the 9th partial sum. I'm gonna do it live. 1 minus 1/4 plus plus 1, 9, minus 1, 16th. What? Oh, no. Oh my. How do you... I don't know how to use a calculator anymore. How do you do backspace? Brand? MC? C? C. Three squared, 4 squared, 16. Plus 1 over 25 minus 1 over 36 plus 1 over 49. I'm at the 7th partial sum right now. I need to go to 9. I need to go to 9. Yes, minus plus 1 over 81. 0.8279 blah blah blah. Write this down. This is our 9th partial sum. Is it the correct answer? No. We stopped. We got tired. Is it the full sum? No, we got tired. 0.8279. Oh, I just went and did it. S9 was, according to we did it. 0.8279 something. We just did it. Okay. Now I'm going to tell you, because I'm a genius. Okay, I'll tell you. I'll tell you what S is. I know this by secret powers that I can't reveal to you this semester. Come join me, become my student 2 years from now. I'll show you the secret powers. So I'll tell you what S is. It's actually I know very, very few actual series, okay? It's actually pi squared over 12. Okay? That's what it is. Okay? You gotta just believe that. Alright. Wait, hold on. You buy that, how the hell do I know it's pi? What a weird number. Beautiful. Yeah, okay, well, whatever. Let's go type pi squared over 12 into the calculator. How do you clear this? Okay, there you go. Pi squared. How do you do squared? I'll just do pi times pi. Divided by 12 equals. Look at that number. 8.8224. Witness. I guaranteed that. I guaranteed it earlier. I guaranteed that shit without knowing S. You don't need to know S to know how far at worst, how far away am I from the true value. This is the glorious thing about the error bound and all error bounds whenever you see the error bound stuff in a math class, okay? It's cool. It gives you some guarantee without knowing the truth. All right, so in your homework, you'll have one error bounding question, okay? And if you pay attention to how I did this one, you'll be able to tease out the homework problem too. One homework problem with error bound, all right? If you have problems with it, ask each other, ask me on Discord. Homework's due tomorrow, Tuesday at midnight. Exam is on Wednesday. All on Discord. Okay. No, like my announcements and all that. Okay. So now I'll tell you a story before we go to the next topic. Story. It's embarrassing, okay? It's an embarrassing story for me. The last time when I taught Calc 2, which was actually the summer of the semester of COVID, when COVID hit us in the middle, like just last spring, I wanted to teach my class a very, very beautiful fact. Okay? I wanted to start off by investigating this series. Notice. I'm going to write it in Sigma notation. Okay, that's right. Okay? Look at that. Just plug in a couple numbers and you'll see it's right. Okay. 4. Sorry. 4 times. Okay? Okay. Now, if you look at this series, it is real good like alternating series. Terms are getting smaller and smaller, going to 0. Think about it, folks. Okay? So, this thing converges. And I know every time Math Mama keeps asking, what does it converge to? She can't help herself. She's so excited. She wants to know, what is the, okay, what is all this converges and not? Tell us what the number is. Okay, so one day I will teach you soon that this number is pi. This one is pi. Amazing, stunning. Pi has something to do with the odd numbers. Look, you put the odd numbers like this, then you alternate signs, multiply by 4, of course, and that's pi. Beautiful. So I wanted to teach my students this. I wanted to say, hey, let's try to witness this by looking at the partial sums. So I started looking at these partial sums. And if you look at what the error bound tells you in this case, B-boy, you're exactly right. So I went up to the board and we started doing the partial sums. I was conducting the class. I was like, there were many people with many calculators ready. I was like, okay, let's go. First partial sum, second, third. Now do 4 minus 4 thirds plus 4 fifths minus 4 sevenths. Now do this. Add 4 ninths. Now subtract 4 elevenths. Now add 4, press enter. Tell me these numbers. And I started listing them. Really, like, carefully. And what I noticed was that the numbers, yeah, they were kind of looking like pi, but not nearly as close as I wanted them to look. So let's look. Let's see what was happening with this particular series. If you try to guarantee using the error bound, what does the error bound formula tell us if you want to guarantee an error of 0.01? Just like last time I did this example, notice we got really close. S9 was 0.01 at most away from the true value. And you only had to go 9 terms. All right, but what about this one? Yeah, I tried it. Okay, What does the error bound guarantee? What we should do which 4 over 2n minus 1? Which step size is at most 1 over 100? Because that step size is what goes on the right-hand side of the inequality. It's the step size. Which step size guarantees smaller than 1 over 100? Which n? Which of these? So I do that. If you do that, look what you get. Look what you get. You get 400 less than or equal to 2n minus 1. Something like this, okay? 400. Okay, let's do some 399. Okay, no, 401 over 2. Okay, look what this is telling you. You need to do n about 200. Or 201. All right, so the error bound guarantees that the 200th partial sum is error bound guarantee. And I hadn't thought about that before showing my example, my class this example. And so there I was in front of thousands of students at the board telling them, okay, now let's do partial sum number 30. I'm sure it's going to get close to 3.14. The 4 never came. We barely got to 3.1 blah, 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 blah after like 50 partial sums or something. And I was sweating. I was like, this demonstration really sucks because I'm claiming that this thing is pi and it looks like it could be any number. It's not getting close to pi at all. It's just 3.1 right now. And I didn't anticipate that I'm going to have to go about 200, turns out, to guarantee an error that the first 2 digits are locked in. And so like this class kept going and kept going. Students started sighing, just like what's happening right now. They started like picketing. And they signed a petition to try to get me fired. They said, this guy made us calculate for 50 minutes saying that this thing was getting close to 3.14159, whatever. And all we saw was 3.1. Who knows what he's teaching these people? So that's the story time. I did that and I learned from it. The error bound can guide you. Don't do that demonstration live when you teach this subject. Because look, the error bound is giving you some sense. Where do you think you should look in order to guarantee an error of 0.01? You should start looking at the 200th partial sum, which means you don't do it live in class. All right? But it's still true that this real good-like alternating series does add up to pi. It just takes a bajillion years, way slower than how fast this series converged to pi squared over 12. It's a fascinating world, really. Okay, let's move on. That was the worst story ever. Okay, moving on. Moving on. Now, I'm going to switch gears. Yeah, 3.13. I swear. B-boy. I swear, it just kept going like 3 point... to even get to the 1, 45 minutes went by. Like, I hadn't anticipated this because I'd I'd forgotten. B-boy. Okay? Look, I'll admit. It's just like 3.07 and then 3.2. And is it doing this? It took me forever to just get the first digit right. Yes, exactly, FS Rooster. It's because I planned my lectures so thoroughly that this happened. But somehow, I don't know how, but the class forgave me. They're good people. They still come in to the lecture every now and then. They were the original crew that helped design this place. They're the first architects. So they hold a special place in my heart. But they've got this blackmail. They have this power. They can reveal this at any moment, and my whole reputation will be just shot. But anyway, so moving on. I'm now going to show you, or we're going to start talking about two very powerful further tests. Okay? So 2 more tests. And after these 2 tests, you're done. Meaning, these are all the techniques we're going to introduce as far as figuring out whether a series converges or not. That's it. After these 2, we will start putting all the different things we learned this semester together. And after we do that, will you have the power to see that this is pi. Only after we put everything together. Okay? So let's learn this. Moving on. 2 new tests. I would say these are the most used test, I would say, in our class moving forward. Possibly most powerful. Okay? Incredibly powerful tests, okay? The first one's called the ratio test, and that's the one we're going to focus on now and all of tomorrow. Wednesday. And then root test will come on Friday. Okay? Ratio test. That's what we'll see. Okay, so what I need to tell you about is the idea behind the ratio test. So the idea is this. You have some random series. You have some. Have some is one word. You have some random series. You have no idea what it's like. Yeah. You notice it's not geometric because that's the first thing you do, right? I hope that's the first thing you all are doing. Just go look at it. Is it geometric? If it is, good news. You know everything about it. If it's not, okay, that sucks. Maybe there's still some hope. Maybe I can compare it. Is it a positive series? Blah, 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 blah. Chain of reasoning. You have this random series, okay? It's not geometric. That's really sad. Okay? But maybe if you take your glasses off, you all have glasses because you're in a math class. Maybe if you take your glasses off, it's all blurry like. Maybe then it feels like a geometric. It starts looking more and more like a geometric series at the end. Maybe it, in some sense, has some characteristic of a geometric series. Maybe when you blur your eyes, it starts to look like there might be a common ratio. That there might eventually be a common ratio. A common blurry ratio. This is not going to make any sense. I have to do examples. But this is the idea of the ratio test. The ratio test says, look, I know not all series are geometric, but maybe if we have a way of kind of investigating how far away is this series from being geometric, maybe that will give us a leg up. Okay? So I'm going to tell you the first thing that the ratio test demands you to write down. The ratio test demands. First asks you to do the following. It says, write down the ratio. See why it's called this? Write down the ratio of successive terms. Write down the next term divided by the previous term. And I just want to know the raw amount of it. Just like in the geometric series. You want to know how big the common ratio is, positive or negative, the size of it. And you like it if it's less than 1. And you don't like it if it's greater than or equal to 1. So the ratio test says, you know what? Screw it. I don't care if there's a common ratio or not. I'm going to ask you to take the next term and divide it by the previous. For all of them. All n. Write them down. Now, for a random series, these are not going to be the same number. There is no common ratio if you're not a geometric series. But the ratio test says write it anyways. Write these ratios down. Of successive terms. Okay? First thing it asks you to do, you just gotta learn how to write a fraction with absolute value bars. Then it says, I know you're panicking. Doesn't look like there's a common ratio. These fractions aren't all 1/2. I know. You wish they were. I know. But what I want you to do is blur your eyes and look at the end of this list of fractions. We now know how to look at the end of lists, okay? So this should not be something you're scared of. It asks you to do this. Second step, look at that. It says, I know they're not all one number, but crank the n up. Look at the ratio of the 10 trillionth term divided by the 9,999,999th term. Take that limit. If it exists, we can proceed. Okay? So it's going to say, if it exists, let's continue. We can proceed. Give it a name. L for limit. Okay? And then the third thing it's going to say after that is an amazing thing. If L is less than 1, then the series converges. And not only does it converge, it converges, in fact, absolutely. Best kind. Very similar to geometric series. If the common ratio is less than 1, you got yourself a convergent geometric series. This is saying similar. It's saying if the eventual common ratio, the blurred out eventual thing that's taking the role of a common ratio, that's what this L is after all. If that thing is less than 1, you've got yourself an absolutely convergent series. And then the other cases, we'll talk about it. Okay? I don't want to push too much on you right now, but it's marvelous. This is an amazing, ingenious idea. It's trying to get a rando series to kind of fit the mold of a geometric series perfect situation. That's why the ratio test is so beautiful. It's kind of like a random series doesn't have a common ratio, but maybe when you blur your eyes and look towards the end of it, it seems like the successive terms are kind of in common ratio. This L. Then you stare at that L and arrive at conclusions. Okay, so that's what we'll learn Wednesday and then also Friday. Thank you for staying tuned. Class is hard, I know. Material is getting harder and harder. That's just how it is. It is what it is. So keep chugging along. Don't cheg, but keep chugging along. Ask each other questions in the Discord and do your homework together on Tuesday, as you usually do. Together, not on Chegg. Okay, now look at this chat. Okay, lots of degenerates here today. No BMP, please don't give us an L on our tests. That's what B-Boy said. So who makes it in the credits? Let's roll credits. Credits equals dopamine hit. Okay? I've discovered this. I'm onto something here. Alright, so how did it start? It started with Just a Human and Battlestorm. These are regulars here. They're students, and they were both teachers' pet. Okay, that's how it started. Now, Shrek came to class. So that's an achievement. Now, what else happened? Let me look through this degenerate chat here. Okay, we've got the usual suspects. Well, here we go. We have a great celebrity. Smash Time Fools. Now, you all don't know Smash Time Fools, but he's a hardcore mathematician. So be careful what you say. They know all this stuff way better than me. Okay, they actually do analysis. So okay, so next and they're a moderator here, so they can ban you at any moment. Who else was here? Worthy of note. Okay, so we've got these people. Okay, we've got the usual suspect. Tori. Anonymous. Hot Tamale. Hot Tamale here for once? Oh, Macaco was here. Hot Tamale, there you go. That's what I thought. I thought I saw you in there. Alright. BPS. My brother was here. Making sure the chat was clean, not filled with garbage. Open Set, a great celebrity was here. We had a great celebrity. Go check out OpenSet's stream. It's actually amazing. They use a microscope and a piano at the same time. Can you believe that? And there's math in there. What more do you want? All right. Of course, Kappa. Kappa is the universal student. Not sure what Kappa does, but they're French, so you don't want to probably, don't ask. All right? So Kappa is French and great person. All right. So then, after that, who else deserves some dopamine? Anyone else want some dopamine? Let's see here. Who are these new people? Oyo Cult Prisoner, why are you gifting subs? You don't have to gift subs, Koyo Cult. Koyo Cult? Koyo Cult. Okay, well, I mean, Koyo Cult. I mean, you made it. I mean, you don't have... You can get on the credits easier than that. You don't have to do that. Okay, here you go. Fine, here you go. You don't have to do that. Don't do that. You can just look. You can just ask next time. Ask. Hey, can I be on the top of the credits? And that's good enough. All right? Okay. Crow. Wow. Crow paying the bills? Incredible. I don't know what Crow does either, but Crow is cool. There's not much room, Koyo. I'm sorry. I'm sorry, Koyo. Okay. All right. Hey, B-Boy. What about B-Boy? Where's B-Boy in all this? Right? These are my students. Thanks for coming. Go home. Go outside. Stay away from people. Go outside. Get some exercise. Stay sane through this crazy time. All right. Hey. Who is Pund? Who's Pund? Pund is a new friend. Welcome. Have a nice day. FS Roosta wants to be in here. See? Look at that. Look at that. FS Roosta. I'd forgotten about FS Roosta. Okay? They decided to say goodbye. But what's the real reason? It's so that they can make it on the credits. I know these tricks. Humans will do anything for dopamine. Nice. All right. Awesome. Boss on camera. I thought I finally found a math stream where a random streamer was teaching math. I'm sorry to disappoint you on your very, very specific requirement. Strange kink. Is it my dream to be the most popular mathematician on Twitch? Why not? Yes. That's why I prove theorems. And that's why I do math. That's why I went to grad school. And I've always wanted to be a mathematician since 10 or whatever, 14 or whatever. That is because I anticipated that there would be a place called Twitch and that I would then be the most, yeah, you're figuring it out. I already have the jacket, so I'm halfway there. That's right. That's B-Boy is right. BMP Dream is shaped like dollar signs. Have you ever considered doing physics for PhD? No. Oh, you mean when I was young? No. No, I was hooked on math. Hooked on math, students. Math. With an A. So that's with that we end the credits. Error bounding, the good like alternating series. Let's do that. Credits, let's go. Here we go, nice and slow. Crow and Oyo. Well-deserved top spot. Just a Human Battlestorm. Keep spamming the Discord. You guys are great. Shrek. Saving the class whenever I call. B-Boy, Tori, Anonymous, Macaco, Hot Tamale. Usual suspects. Open set. Overall, just great celebrity. Kappa. You are you. Pund. I'm running out of positive things. Pund. New. Roosta. Nice. Math. Math is great. Especially error bounds. Boss on camera. Hello. Can't read these. Who is this? Kappa? The color scheme. Can't. Mice. Hello there. I'm a runaway doctor, if you were asking. To work on PDEs. You're a runaway. You're on the loose? Do you have any books, tips for mental math? Have you seen me add 2 numbers? Alan? You must be new here. Class, am I the person to ask for calculation ability? Class can answer that. Have you seen me add 2 fractions? And yet, I'm a mathematician. Because math isn't about calculating. It's about ideas. It's about marveling at things like the ratio test. Seeing this strategy of, you've got this promised land of geometric series. And then you have all the other garbage. But maybe the garbage isn't so far from being geometric. That's an act of creativity. To be bold and daring, to think, maybe I can make a random series in the limit start looking like a geometric series. Start having a common ratio, L. L for ratio. If that eventual common ratio, which I've just invented, if that's smaller than 1, hey, maybe, just maybe, this garbage series will still converge. None of that required me to add 1/3 plus 2/7. I still can't do that problem. I still can't do that problem. The mic sucks? This like $1 trillion mic sucks? What are your other professors using? Aren't they just using their iPhones or something? Oh. MLC. Really? You don't like the MLC? I thought the MLC was great. I think the MLC is great, actually. I think your opinion is wrong. Is wrong. It's factually wrong. Yeah, B-boy, use all the resources that you can. Use every resource. Okay, boss. Nice to see you. Thanks for joining all the way from Japan. Japan. I always wanted to go to Japan, but haven't been able to. Tutoring sucks, period, this semester. Doesn't everything suck? Yeah. Everything sucks. No. Everything is just COVID. Like, everything is at a lower standard. This class is different. Yeah, this class is different. Oh, really classy, Kappa. Nice. But this class is different. Yeah. Exception. There's one exception. But hey, the remaining people, what did you think of my story? Was it on a scale of 1 to 10? Where was that story? That's a good answer, Just a Human. That's a really good answer. Good story, 10 out of 10. Pie out of 10. How out of 10. GoPokes has been reading nerd math blogs. Is that GoPokes? You've been reading nerd math blogs? Why do you know what Tao is? B-boy. It was not very believable out of 10. No, I swear. Hey, is Lettuce Burger out there? Lettuce Burger sometimes shows up or is lurking. Lettuce Burger can confirm. Can't believe I'm saying these things. It's just such a funny world. Lettuce Burger. Anyways, if you see someone named Lettuce Burger, Kappa, ask them if this happened or not. I was literally sweating because like it struck me in the middle. Like, oh yeah, what does the error bound say? Oops. Wait. Kicked and banned from the lobby. What is this? What is this toxicity in my chat, Anonymous Cowboy? When did you realize it though? About the 10th one. Kappa? About the 10th one. Like I could feel the pit stains starting. Yeah. Like the, you know the feeling. All the nerves start tingling, like. Yeah. It was bad. It was bad. And then somewhere in the middle, the class divided into half the class who thought it was funny and wanted to keep supporting me, and the other half which started writing letters to the dean. I just saw them. They just got their iPads out, started writing emails. Get this guy out of here. And that division just stayed forever. No, the professor was wrong. Dunk on him happened in Calc 3 in the summer. Yeah. I made a mistake during class. And You see, Go Pokes, when you have your own class and you're teaching, pay attention to the following thing, okay? You might make a mistake. All right, you added 2 fractions wrong, whatever. What you do next determines the fate of the whole class. Almost impossible to get out of this situation. You could just be like chill at like what I did, which was, you know, okay, I suck at math. Big deal. Look, I made a mistake, whatever. Then there will be that one troll in the back. They'll say, "Wow, look at that. You made a mistake." So yeah, that troll made it. Or you can like resist and be like, oh, there was an earthquake or something. I don't know. Make up something. But then the class will be like, Professor Patel makes up excuses whenever he gets a problem wrong, and he doesn't let us have excuses on the exam. So be careful. Be careful out there, Go Pokes. Yeah, so you're gonna have students one day. All my students will have students. I believe that. And you'll start to understand the first professor problems. That's how that quote made it. Your blackboard, you're using an Etch-a-Sketch, B-boy? You've been using an Etch-a-Sketch this whole time. That's impressive. The Rate My Professor reviews? Yeah, but those are kind of a joke. I don't know if you've noticed, the Rate My Professors is kind of a scam. Anonymous, did you read the Rate My Professor carefully? Did you see what the second or third testimonial was? You should go check it out again. Don't say anything here. Just go check it out. Oh, Professor Peter's here. Yo, what's going on here? What's with the delay? All right, class. I'm out of here, but Professor Peter's here. You should ask Professor Peter everything. Anonymous, I told you not to say what happened, but okay. This class, man. This class. I give one instruction, a simple instruction, and they can't do it. I say, there's an exam on Wednesday. And then half the class doesn't take it. I say, look, Anonymous, go read it. Don't say anything. First thing, they type it. This class. Exactly, Kappa. Kappa, who's this? Vera Benzina. Who's that? Welcome. Exactly, Bira. That's the right way to go about it. Exactly. You're here for the math? Not much math happens here. Just warning. It's mostly just a bunch of people spamming the chat with crazy comments. Toaster? Because it wasn't a permanent position, dude. It had a time limit. Wait, what's going on here? 10k channel points. Oh yeah, B-boy. Teaching has that. What you aim for is something called tenure. But getting tenure is very difficult. That's right. It's a sus job market. No, but it's also Harvard. You don't ever go to Harvard expecting to stay there. That's just... You're just setting yourself up for a life of disappointment. Okay. All right, everyone. See you later. Marvel at the Airbound, at what it tells you. The power of it. No, B-boy. It's not. It's not. No. All right. If I was still there, I wouldn't meet you, B-boy. I wouldn't get to know you or Arbitrary. Well, Arbitrary maybe. Anonymous. All these people. Go Pokes. Yeah. All right. Take care.